Hi everyone. Ever wondered why a pack of instant noodles can last for years and still cook perfectly in minutes? With over 120 billion packs eaten worldwide every year, there must be more to it than just preservatives. Join us inside the world's biggest noodle factories to uncover the science that keeps them fresh. Instant noodles were born in 1958. Momofuku Ando tackled Japan's post-war food shortages. People lined up for hours for fresh ramen. Ando envisioned a meal that's cheap, fast, and shelf-stable. His creation swept Asia in the 1960s. And hit the US in the 1970s. It became a staple for students, night workers, and busy families. Production starts with flour. Trucks dump tons into towering silos. Automated mixers kick into action. Spinning arms blend flour, water, and salt into a 200 kg dough batch. Sensors keep moisture at 30 to 32% to avoid stickiness or crumbling. The dough rests for 20 minutes, letting gluten relax to prevent tearing. Rollers flatten it into sheets thinner than paper. This strengthens elasticity for that springy bite. Blades slice strands at 500 cuts per second, dusted with starch to prevent sticking. Steaming at 100 DGC for 1 minute locks in texture. Flash frying in 140-160 DGC oil follows. In under 2 minutes, 80% of water vanishes. This creates a dry shield against mold and bacteria with no preservatives needed. Hot air dryers at 70 to 90 DEC reduce moisture below 10%. Hydraulic presses shape noodles into blocks. Have you ever eaten an old pack of noodles and wondered if it's safe? Comment if it feels handy yet eerie. Flavor comes from giant kettles cooking broths, chicken, beef, or spicy. These are dehydrated into powder or oil packets. Machines drop noodles and seasonings into foil-lined wrappers, sealed in seconds. X-ray scanners and taste tests ensure no flaws. Lines churn out 600 packs per minute. But here's a twist. The US now out-eats Italy in pasta. Yet a hidden chemical could spell trouble. What's lurking in your spaghetti? America has surpassed Italy as the top pasta market. Barilla's blue boxes are everywhere. Starting as a Parma bakery in 1877, Barilla now produces 3.2 million tons yearly, claiming 33% of US dry pasta. High heat drying can form acrylamide. The European Food Safety Authority flags it as a health risk if it builds up. Can you guess how factories keep your pasta safe? Durum wheat semolina, high in protein, enters mixers with water at a 130 ratio. This forms a stiff 200 kg dough batch. Extruders push it through dies for shapes like spaghetti or fusilli. Acrylamide can bind to proteins in the body, raising cancer risks if accumulated per EFSA studies. Barilla's precise temperature and humidity controls keep levels far below safety limits. This makes pasta safe for daily meals. Machines pack 230 blue boxes per hour per line. Barcodes ensure tracking. But what if your favorite comfort food hides a banned ingredient? Mac and cheese traces back to 13th century Naples with De Lasani's pasta and cheese. In the 1700s, James Hemmings, Thomas Jefferson's enslaved chef, trained in France, brought a refined version to America's state dinners. Kraft's 1937 boxed version, born during the Great Depression, now sells over 1 million tons yearly in the US. Its orange powder once used titanium dioxide, banned in the EU from 2022 for genotoxic risks. Titanium dioxide can damage DNA in cells, potentially leading to mutations and cancer if accumulated, per EFSA. Is your mac and cheese safe to eat? Durum wheat from North Dakota is milled into semolina, tested for quality. Extruders form macaroni tubes, dried at 80-90 DEGC to under 12% moisture. Milk is tested for antibiotics and bacteria. Failing batches are discarded. Pasteurized at 72 DEGSC for 15 seconds, it's curdled with rennet, pressed into cheese. Titanium dioxide was once used for whitening, now replaced with natural colors to avoid risks. Cheese, milk fats and seasonings are spray-dried at 180 DGC into orange powder. Tested for solubility. Machines pack 200 boxes per minute, scanned by X-ray for contaminants. type "No" in the comments if you keep eating mac and cheese despite its past. Noodles last year thanks to flash frying, not preservatives. Pasta dodges acrylamide with controlled drying. Mac and cheese adapts by ditching risky additives. These foods aren't simple, they're feats of science, engineering and quality control. Want more factory secrets? Subscribe and like. What food do you want us to explore next?
Australia's beef industry is a global powerhouse, and at its heart are cutting-edge processing plants that process more than 20,000 head of cattle every day. These aren't just cutting-edge hubs, they're the future of meat production in Queensland and beyond. What's the first thing that comes to mind when you think of a processing factory? Leave a comment and follow Trending Farm's journey to see if it resonates with you. The people powering these processing factories are as impressive as the tech itself. Take John Mitchell, a facility manager at JBS Beef City in Queensland, who spent 20 years in the industry. The machines handle the heavy lifting now faster and safer than I ever dreamed, he says. Alongside him is Sarah Newen, a robotics engineer who fine-tunes the systems. They work in spotless control rooms, monitoring screens that track every step of the process. These facilities, scattered across Australia's beef belt from Queensland to Victoria, process millions of kilos of beef yearly. It's a far cry from the manual labor of decades past, and it's all centered in these high-tech processing factories. Where does this magic happen? One standout is JBS Beef City, a processing factory that handles up to 1,400 cattle per day. Cattle arrive via automated gates, guided into pens before entering the gleaming stainless steel interior. The facility spans 26 hectares and employs over 800 people, blending human skill with machine efficiency. This place runs like clockwork, John notes, pointing to the seamless flow from pen to production line. These processing factories aren't just big. They're designed to meet Australia's role as the world's second largest beef exporter. Have you ever wondered where your steak really comes from? Now let's dive into the machines that make these processing factories tick. The star is the automated stunning system, using AI-guided bolt guns that deliver a humane knockout in under a second. Then, there's the robotic carcass splitter, equipped with laser-guided blades. It slices a carcass in 0.2 seconds with 99% accuracy, far surpassing human precision. Conveyor belts, moving at 500 carcasses per hour, tie it all together. This tech cuts human error by 95%, Sarah explains proudly. These systems cost upwards of $5 million each, but they pay off by boosting output and safety. It's a high-stakes investment for a high-reward industry. So, how does a cow become a steak in these processing factories? It starts with the cattle entering via automated gates, stunned instantly by the AI system. Next, robotic arms skin and split the carcass, guided by sensors that adjust for size and weight. Finally, the meat is chilled in massive coolers, dropping from 38 DGC to 7 DGC in hours before packaging. The entire process takes less than 20 minutes per animal, a speed unthinkable without automation. It's clean, quick, and efficient, says Tom Reynolds, a veteran cattle farmer who supplies JBS. Efficiency is king in these processing factories, but does faster always mean better? Why does all this matter? These processing factories feed a hungry world, supporting Australia's $13 billion beef industry. They meet soaring global demand. Think 2.8 million tons exported annually while cutting waste and labor costs. Yet, there's debate. Some worry automation reduces jobs, with traditional abattoirs employing 30% more workers than modern sites. Others argue it's greener, slashing water use by 15% compared to older methods. This keeps us ahead of the game, Tom insists, nodding to the export ships loaded with beef. What do you think? Does high-tech farming help or hurt rural communities? This revolution didn't happen overnight. In the 1,980s, processing factories relied on manual labor, slow, risky, and inconsistent. By the 2000s, automation crept in, and today's systems are a $500 million leap forward. Compare that to the U.S., where similar tech lags 5 to 10 years behind Australia's pace. We've rewritten the rulebook in 20 years, Sarah says, reflecting on the shift. These processing factories now churn out 25% more beef per hour than their manual ancestors. It's a story of progress, but is newer always better, or do we lose something along the way? In short, Australia's processing factories are a marvel of modern farming. They blend million-dollar machines with humans who know how to deliver beef faster, safer, and smarter. From the original breeding cows to the sizzling steak, it's a system built for tomorrow. This is the future, and it's on your plate, John says with a grin. Next time you bite into a burger, think about the processing factory behind it. Why is crocodile skin known as the soft gold of the luxury world, fetching tens of thousands of dollars per piece? How are millions of crocodiles farmed in China each year for their valuable skin and meat? This billion-dollar industry remains shrouded in secrecy, from breeding farms to processing factories. Join us as we uncover the hidden truths behind crocodile farming. What predator has a 3,700 psi bite force, stronger than a great white shark, yet is farmed by millions in China? In the late 20th century, as crocodiles faced extinction from overhunting, farming emerged to meet the growing demand for luxury leather and exotic meat. Li Wei, who started his farm in 1995, recalls, "People thought raising crocodiles was impossible. Now it's my fortune." Today, China produces over 2 million crocodiles annually, competing with Thailand, Australia, and Africa. Farms use 1.5 m high concrete enclosures, controlled breeding, and precision harvesting in processing factories. The largest facility houses 30,000 crocodiles, ensuring efficiency and secrecy in this billion-dollar industry, where demand for crocodile meat and leather continues to rise. Why do crocodile farms control incubation instead of relying on nature? In the wild, female crocodiles fiercely guard their buried eggs, but on farms, workers collect them at night to avoid danger. Incubated at 29 DGC to 34 DGC, these eggs hatch in 65 to 90 days, with temperature determining gender. Conservationist Dr. Zheng Wei argues natural incubation creates stronger crocodiles, while farmer Li Jin, who raises 50,000 crocodiles, believes controlled methods ensure survival. After hatching, baby crocodiles move to protected aquariums, feeding on ground fish and chicken heads before transitioning to whole fish and raw chicken. Crocodiles are sorted by size to prevent aggression before reaching the processing factory, where farming efficiency meets ethical debates. What do you think? How does controlled feeding impact the quality of crocodile meat and skin? On farms, young crocodiles start with ground fish and chicken heads, while adults consume whole fish, chicken, and other protein-rich foods. Each crocodile eats 5 to 10% of its body weight per meal, ensuring fast growth and optimal skin texture. Compared to the wild, farm feeding reduces disease risks and prevents injuries from food competition. However, a lack of dietary variety may weaken natural immunity. Studies show that farmed crocodiles reach farmed size in 2 to 2.5 years, faster than their wild counterparts, but may develop softer skin. Before entering the processing factory, crocodiles undergo strict feeding management to enhance meat texture and leather quality for high-end markets. How does China process millions of crocodiles annually? And is advanced technology making the industry more efficient? At 2 to 2.5 years old, crocodiles reach 5 to 6.5 feet long and weigh 55 to 77 pounds, the ideal size for harvesting. The process begins with electrical stunning using 110 to 220 V equipment, ensuring quick immobilization to reduce stress and preserve meat and skin quality. once stunned. Hydrolifts move the crocodiles onto processing tables, where laser-guided skinning tools make precise cuts to prevent damage. Meat is vacuum sealed and flash frozen at -40 DEFF to maintain freshness. However, high-tech automation remains costly, limiting widespread use. Should processing factories invest in advanced machinery, or does traditional manual processing still offer the best balance of cost and efficiency? Pen-dot crocodile meat is a delicacy in China, particularly in Guangdong province, where Maoming leads in crocodile farming and meat production. Other high-consumption areas include Suzhou and Sanya, where local markets cater to increasing demand. Prized for its high protein, low fat, and medicinal benefits, crocodile meat is often used in grilled dishes, stir-fries, and herbal soups, believed to boost health. Retail prices range from RMB 50 to 58 per pound, $7.60 to $8.80 per pound, making it a premium ingredient. While chefs praise its chicken-like texture with a hint of fish, consumers remain divided. Some value its novelty, while others question food safety and bacterial contamination risks. What do you think? Would you try this exotic meat? Crocodile leather is one of the most coveted luxury materials, undergoing an intricate tanning and dyeing process to achieve its signature softness, durability, and refined texture. Top luxury brands meticulously select the finest grade-eye leather to craft handbags, wallets, and shoes, ensuring each product meets exacting standards. Some handmade crocodile leather bags fetch prices exceeding $50,000, making them symbols of prestige. Crocodile farming is a multi-billion-dollar industry blending tradition, science, and commerce to meet the growing demand for exotic leather and meat. However, ethical concerns remain controversial.
AI technologies are gradually developing and created by human hands. What if each processing factory gradually has fewer people working? Please share your thoughts below in the comments section of this video. And lastly, don't forget to recommend the channel to your friends so they can watch too. Thank you and goodbye. See you again in the next videos.